Greetings to all. Myself, Rushabh Shah. I am pursuing my Masters in Construction, Engineering and Management from SEPT University. So, for the Studio 2, focuses on the concepts related to the construction site where the data are collected and analyzed with the perspective of different concepts, tools and techniques and presented with areas of improvement and develop an understanding of the major aspect of the project life cycle for our project. Our project is located in the city of Ahmedabad, where the objective is to provide a luxurious residential project in the Silaj area. Its main objective is to provide luxurious homes surrounded by the nature in the fast developing area, which is becoming the city's most desirable neighborhood as shown here on the map. The orange line here shows the main road, the yellow line shows the approach road, and the red demarcated line box is our site. Our site is a high-rise residential project. It is in Silaj, Ahmedabad. It is a greenfield real estate project. The built-up area is 1,68,429 square meter. The site area is 17,232 square meter. It has a total of 336 housing units, where the permissible FSI is 1.2 and the purchased FSI is zero point 0.6. It has 22 floors with a total height of 105 meter. My first assignment was floor planning for the formwork. So on our side, pore divided into 18 number of pore. So we took block A as our scope of work. In that block A divided into two pores of the same area consisting of 678 meter square. So starting with the formwork planning, in formwork for the beam and slab, we use conventional formwork with Doka and Tata box, and for the column we use EcoSpeedy formwork. Here is the cross-sectional view of the formwork system of the beam and slab. After this, we calculate the beam plywood. In that, we consider beam sides and beam bottom area and also consider the 5% wastage. After that, we got the number of plywood required for the number of beam bottom and beam vertical. For the beam bottom, 18 mm ply is used and for the beam vertical, 12 mm ply is required. So we got the number of plywood for beam bottom is 16 numbers and 12 number for beam vertical. Similarly, we also calculated slab plywood calculation. In this, we have calculated total pore area. From that, we have deduct the beam total beam area and total column area. And in that, we also consider the 5% wastage. After this, we got the number of plywood required is 219 number. For the direct cost of formwork, we consider elements like GI props, tripod, line, etc. In this, we consider a number of elements, cost per unit. So we got total cost of 23,63,171.45 rupees. After this, we consider the repetitions and we got a cost after repetition is 85,000 rupees 85,312.87 rupees. After this we calculate the beam and slab productivity of 657.12 square meter of an area requires 15 number of carpenter and 12 number of helper working for 8 hours for 7 days, which gives a productivity of 3.48 square meter per man day. Similarly, for column, shuttering productivity of 63.10 square meter of an area requires 6 number of carpenter and 3 numbers of helper required for 8 hours for 1 day, which has a productivity of 7.01 square meter per man day. For the column, they used EcoSpeedy formwork. So for this calculation, we considered various elements like EcoSpeedy panels, and in panels we consider the different panel size and its quantities. For cost multiplied by the unit rate with the derived quantity of each element, we got the total cost is 13,43,944 rupees. and in this we also consider the repetition, and we arrive at a total cost after repetition is 25,221 rupees. After this we also calculate the total laborer cost of 678.88 square meter of area required. 21 number of carpenter, cost is 800 rupees per carpenter, and 15 numbers of helper, cost for this cost is 400 rupees per helper for 8 hours per day for 9 days. So the total cost of laborer is 2 lakh 5200 rupees. After this we calculate the total formwork cost with labor and material. So we got the cost of 3,50,000 15,733.87 for 678 square meter. So my second assignment is a quality lab. In quality lab, we first of all prepare a CAD drawing of our existing quality control lab. So this is the lab layout. Is existing quality lab is 25 square meter, and beside that curing tank is there of 10 square meter. Between the quality lab and the curing tank, there is a 500 width passage. In the quality lab, there is a platform for the equipment and a storage area, etc. available in lab layout. So this is the proposed layout as per NBC and CPWD guidelines. So we proposed wash basin, fire extinguisher, fire buckets, and other than that, we wide the passage from 500 to 1200 This is the proposed quality lab layout. This is the isometric representation of the proposed quality lab plan, which shows the wash basin, working platform, working desk, curing tank, and other elements of the quality lab. The following is a list of the equipment available on site, and to see the 3D model, uh, please scan the QR code. We prepare a 3D model of a quality control lab available on our site. Third and last assignment is material management. In that, we have first of all material requisition process. So for material requisition process, first of all quantity estimation is done by the site engineer, and he enters the detail of which material is required on the ERP software, and then notifies to the site store in charge and the project manager. Project manager gives approval after some other personnel give approval. After that the material arrives on site, which is verified by the store in charge and notified to the billing engineer. After that, store. This is the site store plan. In this, various storage areas are allocated for each material category, like file storage, PP storage, paints, fire foam materials, weighing machine, nails, other tools which requires on site. We prepare a steel storage layout. It consists of steel scrapyard, reinforcement bars, threading machines, cutting machines, and bending machines. After this, we have the classical economic order quantity model, in which we compute the annual demand for steel as 3270.86 tons. This 3270.86 represent the steel's 9-month demand because our project began 9 months ago. We made various assumptions for our EOQ model, such as first one, the steel rate is 50,932 per metric ton. The carrying cost is calculated as 5% of the steel purchase price. Third, storage costs are calculated as 20% of steel purchase. Fourth, for the analysis, 220 working days are taken from the yearly demand of 9 months. Fifth, ordering costs are calculated based on time spent by project manager, senior execution engineers, store managers, at site level. And from HO, we can calculate the purchase engineers and planning engineers. After that, we obtain a total cost of 19.67 crore, which include the ordering cost, carrying cost, and the purchase cost. So the plant shortage model is 74.33 metric ton, while the maximum inventory level is 59.46 metric ton. The base shortfall level is 14.87 metric ton, with a cycle duration of 5 days, including 4 days for inventory and 1 day for shortage. The order amount is 1660.57 metric ton. After this, we have done HML analysis and ABC analysis. For HML analysis, here materials are classified according to their unit prices. Binding wire is in the high category due to its high unit cost. Reinforcement is classified as medium materials which have moderate unit price. Concrete and cement are designated as a low material since their unit cost is lower than other materials. For ABC analysis, TMT bars and concrete belong to the Class A category. The combined cost of these items constitutes 55.66% and 23.21% of the total respectively. This signifies that these materials demand more and intensive control measures. Conversely, items categorized under Class B and C necessitate comparatively less oversight. So for the conclusion, it concerns floor planning, quality lab, material and inventory management. So in floor planning, deliverable made it easy to gain insight into productivity, repeats, quantity and cost of the project's execution. Through it, through the identification of the regions with the highest demand for labor and resources. Planning exercise improves the fundamental understanding of how to schedule a formwork system. After that, quality control. Understanding the requirement for an on-site testing laboratory, determining the necessary equipment and establishing clear communication protocols regarding quality are crucial. The quality assurance plans should be elaborated upon considering environmental factors that may impact quality by the CPWD 2022 manuals. Material and inventory management. Calculating the appropriate stocking capacity using models like EOQ help determine how much to keep on site based on consumption rate. Using an ABC framework, categorizing materials by importance, aiding in cost management, HMN analysis helps control purchases, monitor consumption, and set verification frequencies. These strategies reduce waste and save cost in inventory management. So, this is the studio insight and learning. First of all, the studio provides hands-on training in a range of construction project areas including material management, cost control, budgeting, safety, and quality assurance. After regular site visit, professional lectures, software tutorials, and interactive conversation help participants understand construction management principle, method, and perspective of improvements. Project control was carried out using technology tools such as Primavera, which allow for progress tracking and risk analysis. Using the Primavera risk analyzer in and overall the program improve understanding of construction, project management, monitoring and control, procedure analyze and scheduling. Thank you.